Good morning, everyone. My name is František Hilmar, and today I'm going to show you all about Merbon IDE. This will be training for beginners, so if you are new to our software, this is perfect for you. But in case you have some experience, there could be some things you may not know. So, in case you are interested, I hope you enjoyed today. And first of all, I just want to check if my settings is okay. So, can you hear me well? Or is it too quiet? Okay, thanks. So first of all, I'm gonna introduce today's plan. So in start, I will show you something about our brief introduction to our hardware. Especially today, I just show you some PLCs, process stations. Then I will continue with Merbonide itself, with Merbonide programming. We'll be showing you some basic solution. It means some basic programming for PLCs from our company. I'm working as a technical support in our company, so in case of any problems, uh, don't hesitate to contact us on our email or our technical support line. It's here, so in case of any trouble, just let us know. We'll try to help you as soon as possible. There is always someone who picking up the phones or answering emails, so in case of any trouble, don't worry and just let us know. Okay, in case you want to see some more tutorials, we have our YouTube channel. I assume you know about that because you are here, but you can check it after our stream. You can check, we have short tutorials for some specific operations in Merbonide, and we'll be releasing new ones in a few weeks. If you will not be able to see all this training, don't worry, because they'll be recorded, and after its end, it will be in our channel also. So don't worry if you can't be here for whole training. You can go do your do your thing and then just see it, record it. Okay, I'll just start with some brief introduction to our hardware. So I'll go to our web page and I'll show you. Okay, here, this page, Mark and Wall process stations. In case you're working with our company for a longer period of time, you may know this Mark series. This is our most sell today series. And this year we introduced the wall process stations. So in this training, I will show you also some basics about wall process stations, what series, what PLCs you can buy from our company, and what's the difference between Mark and wall process stations. I would recommend you, if you are starting a new project and you don't know what process station you should use, I highly recommend you to go to our webpage to see this table and see some basic review of the PLC properties. There is also some, I think, maybe better table for you also. It could be useful. And it's this one. Yes. This is also important now. So I will show you this table in a minute. So first thing, which is very important for you when you're starting a new project, is the number of IOs. So in case you need some small process stations, or you are don't planning to use any external IOs, you should check the number of IOs in the set properties here. So you can adjust the number of PLCs used in your project. You can just check the number here, and you can compare the PLCs itself. I think very important thing is this communication port. As you can see right now, we are not selling PLCs without the communication ports. In past, we were used to sell some of these, but today, based on our experience, it's always good to have a communication port, even if you are not planning to add some I/O right now. There may be some use in future, so it's not good to close the door from a communication. It's always good to have some communication possibility on your PLC. So I think this is also very important property. So you can check the number of communication ports, RS 242 and RS 485. One thing that may be very useful also, it's the display. As you can see, the LCD display as shown here in the picture. So some of our stations has this LCD, and right now we have a new PLC that has it, and it's this type IMEO 110. So it's our new PLC which has its own IOs, but it also has the LCD display. So that's the difference, because in the past we only had the ones with IOs or the ones with LCDs. There was not a combination of these two features. So right now it is possible to have a PLC with its own internal IOs and the LCD display also. Okay, so this is basic introduction to our process stations. I think the most useful ones are the Mark MX. It's this one. It's our highly sold product because it has a lot of IOs on it, and you don't need any external IOs when you're using this PLC, and you have a lot of IOs spare. Also very good one is this. This one I will be showing you today. This is the one I have on my table, on my desk, and I will show you the programming with it today. It don't have any internal IOs, but it has doubled communication ports, so it's very useful also. Okay, I will just continue with wall process station, because these are new ones for you, maybe. Okay, I'll just show you here. Okay, so just for a brief summary of this table, very important is the number of communication ports and the number of IOs, if the PLC has some IOs on it or not, or has only communication ports, and you have to buy some IOs if you want to measure some values. And the display is also a very useful thing for making up the project. Okay, so now I'll go move to our new process stations. It's a series named WAL. It was developed with cooperation with Vago or Vago. I don't know what's the right spelling. International, so we call it Vago. As you can see, it's pretty same. It only has our label on it. The difference between this PLC and the Vago software, it's the runtime. If you are using Vago PLC, you need to use their programming tools. If you buy PLC from our company and it has our label on it, you can use Merbon IDE, our programming tool, to program this process station. The cards are the same. As you can see here, they are not labeled. They are 100% same as are selling by Vago. So you can combine cards, but you can use our system, Merbon IDE, to program your project if you want to use this kind of process stations. There is also a table where you can see some types for our selling products. This is not like you don't have to buy it like this. This is only our series for sale. It means there is some better price on this if you buy it like this compact product like a series. You will receive a PLC and some cards with it, and the price will be reduced in comparison with the PLC itself and the cards separately. So if you buy it like the set, you have these 4 sets, it's cheaper than if you will adjust it by yourself. So, but this doesn't mean you have to use these numbers of IOs. It's just the set number. So you can add some cards on, or you can remove the cards. It is not connected any more than it's normally. It is not some whole product. It's just for sale. So it doesn't mean you can't add more cards or remove some cards from it. The main difference here is the communication card or communication port, which is included only in these 2 sets. The difference between the sets are just the type of the PLC. We have 2 types. One is the W750 with 8101, and the second one is the same number but it's 8102. The 102 type has this communication port on it, so it's here in a place of these dip switches. There is a communication port. I'll show you in a picture. Okay, it's here, you see. And it can work both. It can work as 485 or it can work as 232. Okay, so this is for wall stations. So you can buy either separate PLC and then cards as you want, or you can buy a set, which is reduced price, which is better for you, but it's only for market. It's not some hardware definition. Okay, so this is our offer from these PLCs, and cards are compatible with the Vago cards also. Okay, so in case you are planning some project, you can take a look at these tables to see our PLCs, our offer. The difference between these PLCs are obviously the card system. So in case you want a monolithic PLC, it's easier for you to buy this one. It's easier to plug all the IOs. But in case you don't know how many IOs you would need, or you want to spare some space, you can use this one, because it, as you can see, this one, there is many IOs on it and it's not so big. For example, in comparison with Mark MX, this is very big PLC. And maybe when if you are doing some reconstruction and there is not so much space in some electricity box, you may not have so many space to add the Mark MX. So maybe this could be also useful for you. So this is also an advantage for this type of PLCs. Okay, so this is a brief introduction. What kind of PLCs we are using right now. And I think I can move to the Merbon IDE itself. I forget to mention in start that in case of any questions, do not hesitate to ask me, to write in chat. I'll try to answer as soon as possible. There is some delay, so if I'm not answering right now, don't worry. I may not see it yet. I think there is like half a minute delay from my streaming. So in case of any questions, just do not hesitate to write it. I will try to make some quick breaks during the streaming to for you to ask me, but you can ask anytime during the stream. So in case you are interested in something more about our hardware, you can ask me right now. And in case there are not any questions, I will continue with Merbon IDE programming. Yes, and I see that I forget to tell you about this table also. So I'll continue with this table. This is new to our system right now, because in past all the features from Merbon IDE were supported on every PLC. Right now we add some news to our PLCs. We have a new version right now of our programming tool. As you can see here, it's this sentence. And right now there is some differences because we add BACnet, communication protocol, server and client. We add some advanced web, and we add some features of the web also. So right now it's not equal. All the PLCs are not equal, because there is some with lower performance, and those ones are not supporting all our features, our new features. The old features from our programming tool 2.3 are supported on every PLC, but the new features like BACnet and some features from web are not supported anymore. So in case you are planning some project, this table is also can be important for you. If you are looking for some specific feature, you may check this table to see if all the features are supported on the exact PLC. As you can see, the high performance ones, those ones who are Linux based, it's the upper part of the table, supports everything pretty much. Then the rest of it, they are running on a free RTOS, free runtime system. They don't support all the functions. For example, BACnet are supported on some of these. Those ones with better performance, they are supported, as you can see. Okay, so this table can be also useful for you if you are planning some project. This training will be separated in two parts. In the first part of programming, I will show you some basics. When you are working as a programmer, we are working and you have some time to project, you are not on site. You are in your office and you are trying to prepare the project from release. So that will be the first part. It will be without the physical PLC, how to adjust your project before you go to site. And then I will continue with a hardware, with a physical hardware, how to go to site, how to set the PLCs to right definition, how to set the Modbus devices, and how to make it work on site. Okay, so I'll just continue with Merbon IDE now. In case you are new and you don't know how it works, you can download it for free. It's completely free. And it's here, Merbon IDE. There's also some other softwares, but this is most important one if you are working with PLCs. The last release is also here on the top, and the oldest versions are here. So in case you want to try something with me today, you can download it here, our latest version, and you can go with me. Okay. I'll just continue. The installation itself, it's nothing special. You just start the installer and it will be installed on your computer. And there'll be two icons on your desktop. This icon, it's the programming tool itself. And this icon, it's for Windows runtime. This is some kind of a virtual PLC. In case you don't have a physical PLC, you can use this one to act as a PLC. So your computer will act as a PLC, and you can try your project, your definition, if it's working, if the program is good, if everything is set right. If you are familiar with our system, you may see that there were three icons after installation in past. There was also Merbon HMI. Right now it's not here anymore because all the features which were in the HMI are now in Merbon IDE. So it's easier to program it because you don't have to use multiple program tools to make HMI definitions visualization. So I'll just start it. In case you have multiple versions, you will see this table. In case you have only one version, it will automatically continue and start the program. The purpose of this approach is when you have some old project and you just want to change some little things, you are not interested in new features, you don't have to open it in the new version. You can keep it in the old version and it will be automatically open in the old version if you have it on your computer. It doesn't mean that the projects can't be open in the new version. You can actually open it in a new version and to use new features. But in case there is some changes, slight changes in the definition, you may need to, for example, attach PLC one more time or to do some slight changes. And in case you are not interested in these features, it may be better for you to open it in the old software, on the old version. This will help you to do not have more work to do than you have to do. So it is easier to open it in your old version if you don't need to change some things or add some new features. But you can also open it in new version and to use these features, but it's only for you to make it easier for you to work with it. Okay, I'll just start this version, the version we are using today. And the screen will open. You may notice I have it dark, maybe you have it light today. This is some basic settings here. So if you click Tools, Settings, you can see there is a color theme. You can change from light to dark in case you want it. And you can also change the language. I assume you are working today with the English version, but there is also Czech language or Turkish. So in case you're from Turkey, you can use this option also. Okay. It's similar for every program right now. We'll start with a file here, clicking in File, and we will try the first option, New Solution. It's this option, or you can click here also New Solution. It's here in the header bar. Okay, so we'll click New Solution. It will create me our project. I can name it like training okay, and there is always good to choose some of your okay, so here some folder for it. In case you click this checkbox, it will create a directory for your solution. So there will be folder and there will be all files in the folder. Okay, I'm okay with this. And now we are going to very important option if we want to start our solution in simple or full mode. In simple mode, there is some limited functionality, sorry, but it's easier for use because some things are done for you. You don't have to adjust everything, set everything. Something is automatic. But it can be problematic for you because there is some limitation. I think the most important one is that in a simple mode, you can only use function block diagram programming language. So there are two programming languages in our programming tool. We use structure text and function block diagram. In case you are working in a simple mode, you can only use function block diagram. You are not able to use structure text. So in case you want to use structure text programming, you have to go with full mode. Today we will work in a simple mode to show you some only basic introduction. There is also one very important thing, the very other important thing, which is in simple mode, you can only work with one PLC in your solution. So it assumes you're working with one PLC. In case you want to work with multiple PLCs in your solution, you have to use full mode. Okay, so this is also very important difference. Then there are some other slight differences, but there is, I think these two are most important ones. Maybe I will add one more because this can be also important. In case you want to store values in history in your PLC, because this is also a new feature from this version 2.4. There's a new feature that you can store some values, some history in the memory of the PLC. And this feature is also supported only in full mode. So maybe these three are the most important ones. Okay, but today we will work in simple mode. In case you are interested in features I mentioned, you can take a look in our previous training, which was Merbon IDE Advanced, and there is some more information on working in full mode. Okay. Today we will do a simple mode. For most of the applications, if you are using just one PLC, you can work with in a simple mode. I think this sentence is best one because it says if you are not sure now, select simple mode. Okay. You can see that right now there is slight change and something appears here in the left bar, in the left column. Okay, when I click something, when there is a focus, you can see that something also appears in the right part of the programming tool. I think this is most important is to tell you how works our programming tool, how it's done here, how it's separate. So the left part, there is some structure of your project, basic structure. If I just hide all the branches of trees, you can see there is three main parts of it. The first one, it's called system. This part includes all your hardware definition. So all your PLCs, terminals, channels, communication ports, IOs are here. All the hardware definition. And this is your start. You also start with hardware definition. Then you move to executable projects. This is a part when you do the programming, when you create the programs, function blocks, and you can adjust it and then load it to PLC. So this is part for creating your programming. And the last part, HMI projects, this is for visualization. So if you are using LCD display in your PLC or some external one, or if you are using a touchable screen or web in your PLC, in the memory of your PLC, you can use this part of the branch of the solution. Okay, we will go through all of these today. We will start with the system. As you can see, when I'm changing the focus, the right part of my screen also changes. This is because, as you can see here, it's properties. And this part always shows us the properties of the focus of my cursor focus. So when I click somewhere, it changes. Depends what I'm clicking at. This middle part, most important one, this is a working place. This is a place where you're working. If you double click something, it will open you the definition here. Okay. As you can see here, this is a ribbon with all the icons, and the ribbon is also changing depending on what I'm using, where is my focus. When I click the PLC, you can see there is some options here for PLC control. In case my focus is somewhere else, there can be something else here also. So it's just basically for you, for your information, that not all the icons are visible all the time. It's similar to other programs. So if you are using, for example, HMI project, there will be something else. If you are working with PLC, there will be something else here also. So in case you are missing something, it doesn't mean it's not there. It just can mean that you don't have a right focus. Okay, we will start with attaching the PLC. So we are starting your programming. You first have to attach the PLC. So you right click the PLC and choose the first option, attach PLC. Okay. This dialog offers us three options, very important ones. It means how we want to add our PLC. The first one is UDP broadcast. I think this is most common one, and it's working when you have a connected PLC directly to your computer, or if it's some PLC in your internal network. Okay? So in case you have it write it directly to your computer by cable, or it's in internal network, you can see it here in UDP broadcast. In case it's some remote connection, you have to connect to some public IP address. You will use this, deploy parameters. Then you can connect to some remote site, and it will give you back the information about PLCs on this remote public IP address. The last option that we will use right now, it's manual. This option can be used in case you don't have the physical PLC on your desk and you want to program it for some specific type of the PLC. This is an important option because right now we are not able to do any more activity here because the program, the solution doesn't know what type of PLC you are using. It's always a context working. So in case you're using PLC from the Wall series, it will offer you to connect, for example, some cards. In case you are working with PLC with multiple communication ports, with multiple buses on it, it will offer you to add channels to these buses. But in case you don't have a selected type, the program don't know what can offer to you, what options it can offer. So this is how it works. Basically only offers you the options you have. So there won't be any mistakes by, for example, that you choose some communication bus which are not on your PLC, because it will only offer you those ones who are actually there. But you have to choose the type. I saw some programming tools and where there was not an option to change it afterwards. It's not this case. In our programming tool, you can always change it to some other physical PLC in case you have some other type to use. I will show it to you today also. Okay, so we will use the manual right now and I'll click next. In case we know the address of the PLC in advance, we can fill it here. This address is the most common one because it's the address from the factory defaults. So in case you just received our PLC from our store, it will have this address. In case you know the serial number, you can write it here, but you don't have to. Right now we don't know it, so we'll just click on the type of the device and choose the right type of the device. You can see all the devices here, or the possible devices that can be used in your solution. These devices are from the table, which I showed you in start of this training. And today we will use the Mark 420. That's the PLC I have on my desk right now. So I choose this type and just click next. This port, it's a port for communication with IDE. So Merbon IDE, it's communicating by this port with the PLC. So this is why you have to choose the port and the host here, because this port is used for debugging if you want to see the values in your project. Okay, so I'll just click next. Right now I have an option to download the configuration. I cannot use it right now because if I would use it now, it will end in error because I don't have any physical PLC on this option on these settings I used. So I'll just not click the download configuration. I'll continue without it. Okay. Right now you can see some other options are here. The properties are now larger than before. That's because we choose the type. The type is here, you can see it, Mark 420. And because we choose it, there is all these options here now. This is important because, for example, in case you will use a wall PLC, there will be some slight changes here because the wall PLC are using different types of the configuration. So there will be some different options in the properties. Okay, right now we are using the type. So in case you go, for example, to some external project that you are not working on, you always can see the device type here. So in case you don't know the device type, you just click the PLC in the solution and you see it here. Okay. There is some important part here. These properties with a red square are those ones which goes with the project. So these ones are in the memory of the project. These green ones, this is the configuration of the PLC. These options are read from the memory of the PLC itself, from the configuration of the PLC. So in case you make some change here and you want to push it to the PLC, the most common one, for example, is when you are changing the IP address. You have to upload the configuration because only these options are going with project, and this one with the green squares are not going with project. These are a configuration from the PLC. So in case you are making a change here, it's okay. You just have to deploy the project. These are these two buttons. This is for build your solution, and this is for deploy. Okay, I will show it to you later also. Okay, and if you want to upload the configuration, you just right click the PLC, click PLC operation, setup, upload configuration. You can either upload configuration or download the configuration. So in case you want to know what the configuration is in your PLC, you click download and it will be downloaded to your project. It will appear here. And in case you want to make some changes, you make them and then click upload. But right now we don't have a physical PLC, so we won't use this option. Okay. Right now we can continue. We have a type of the PLC, so we can continue with our project. We will use today standard, very easy Modbus communication. We will use a channel for I/O, for MCIO2. It's our I/O module. I will show it to you in the picture. Okay. Okay, here, I/O modules. So you will see the type here. Okay. Okay, here, modules. And today we will use this one. Okay, I just have to choose it here. Okay. Maybe it's not in offer right now because it's the old one. So I will show it to you in our system here. Okay. It's also very useful icon. Help. All the information about the software in case you don't know how to do some operation. You can use the help here. We are trying to adjust it always to all the features, all the functions. So in case you're lost, you don't know how to work with our PLCs, you can go here. There is some very basic, basically all the options, all the operations you can do in our programming tool are described here. Okay, and I can also choose here, there is also our description of all our hardware, so I can show, yeah, this is this module I will use today. It's the old one, it's not in sale right now, but we have some new ones which are used now. I believe right now it's okay. This is the new version of it. Okay, but today we will work with this one. Okay, in case I want to tell the solution that this will be included, I have to first create the channel. Okay, I first have to create a channel and choose the type of the communication. So I just right click the PLC, click add channel. Right now the project knows, okay, I will use the PLC type Mark 420 and there will be one channel. Okay, one channel. So I click on the channel and I have to choose some more properties here. Because right now it's just some basic common channel. There is no protocol chosen yet, so there is no option to add any more devices. So first of all, I'm gonna name the channel. It will be a Modbus channel. So I just name it Modbus. And I'll choose the Modbus protocol here. Okay, so there is the options. The SSCP protocol. This is our proprietary protocol. We use it in communication with our PLCs. And then there is Modbus, BACnet protocol, and the IEC protocol, and then MBus protocol and Soft PLC link, which is used for our older PLCs. So in case you have some old project and you want to combine our new PLCs, our new series Mark or Wall with our old PLCs, you can use this Soft PLC link protocol to communicate with them. Okay, today we will use Modbus. as you can see, when I choose the communication protocol, the property is changed. Now there is options which are important for Modbus configuration. First and the most important thing is this option. If I want to use a serial or TCP. Serial Modbus works basically on 2 wires. It's just 2 wires communication, and TCP is by the normal internet cable RG45. It's the basic one you use when you want to connect to the network, to the internet. Okay, we'll use the serial because I will use the serial bus on my PLC. Okay, there is some communication options. We can skip these, we can keep it as it is here. This is okay for us. We only change this one in case of any problems. So this is some basic property, some basic settings. In case there is some problem with communication, we can adjust it. I think the most important option here is this port number. This is a very common mistake when you do the definition. You connect all the IOs, but it's not communicating. There can be here. There is very often here is a mistake. If you choose the wrong port number here, it won't communicate because you can physically connect it correctly, but you have to choose it here in the project also. So the PLC would know where to in which port are all the devices connected. So you have to choose this between the ports from this menu. Because I'm using Mark 420, there is 4 ports available. Okay, I may show it to you here. Okay, it's this one. So you see there are 4 buses. So this is 242, and okay, I have to pause it here. Okay, and these 2 are for 485 communication, 2 wires, as you can see here. 2 wires, 9 pins here. Okay. Today I'm going to use these 2, and I will use the bus COM3, which is here. So you can see here, this is COM3, so I'll use this one. So I have to choose it here. Okay, I'll use COM3. This serial line parameters as baud rate or data bytes, you can adjust these if you are communicating with some external Modbus device. In case you are communicating with our Modbus device, you can leave it as it is now, because this is our default settings for all our devices, our Modbus devices. So you can leave it like this. In case you are communicating with some external device, you may change these. Okay, depending on the settings. Okay, right now I'm satisfied with it, and I can continue. So in case you have a good configuration of your channel, of your communicating channel, you can add some devices to it. There is also some different approaches to this. Now we are working in our office without physical PLCs, without physical devices. So we have to add them manually. There is also a auto detect function. I will show it to you later. But right now we can just work with these 2, add device or add library device. The first option, you would use the first option in case you have some external Modbus device. This is some general device with no definition in it. You'll have to create the definition here. If you know you are using our device, you can add them from library, and it will be easier for you because the definition of the device will be already there. So you won't be it won't be necessary to create a definition. There will be preset for you. So in case you are using our system, our devices, I would recommend you to always click add library device. Okay, so I'll click it. And you can see there is all the controllers, all the converters, all the room units, everything is here. Everything which is communicating on Modbus and it's sold by our company, it's here. Okay. In case I would change the type of the communication protocol, there will be other devices. So these are only Modbus ones. As I said you before, the program always responds to your action. So in case you choose Modbus, it will offer you only Modbus devices. In case you choose BACnet or something else, there will be different devices here. Okay. Right now there are many devices, so we can either click here and find it in the table, or we can use the filter here. I think this is very important thing, the filtering. Through all of our programs, I think through our Merbon IDE, when there is some table where you have to choose something, there is always the filter on the top of the box. So you are not supposed to go through all the options. You just can filter the one you are looking for. So right now I'm looking for MCIO1 or IO2, sorry, MCIO2. So I'll just write it and I will choose it from the table. Okay, I'll click this little arrow and you can see it's added here in selected devices. Why it's like this? This is because I can add multiple devices. So in case I'm using more devices, I can click, for example, on some other one and add it to my configuration also. So I have to do it one by one. I can find all the units on the serial bus and then click OK. And all the devices will be here in our channel. So now I'm just at one, but you can add multiple devices here. Okay, I'll just add one today and then click OK. Okay, as you can see, the device appeared here. And here in the variable browser, there is some new variables here also. Okay. This works in a simple mode. There is a function for which pulls all the variables to your project automatically. It's called autogen, auto generation. Basically, it will generate you the variables automatically when you add a new device. Sorry. Okay. So it will create all the variables automatically. You can see the analog outputs, inputs, digital outputs and inputs here in the variable browser right now. And if I add some multiple devices, you will see the more of the variables here. As you can see, the variable is always named by the device, and then comes the name of the variable itself. You can change both of these, but there always have to be the name of the device and then the name of the variable. This is for you to be easier for you to find which variable belongs to which PLC. Okay, so you can, but you can name it as you wish. So the definition of the device, it's when you double click the device, you will see the definition. This is a Modbus definition. You can see there are two groups. One is for read and the other one is for write. So read ones are inputs. You can see that there is analog inputs, digital inputs, and in write section there is analog outputs and digital outputs. Okay. So this is the Modbus definition. This is how it looks. And you can change the definition here. In case you are working with a general device, you have to create this table for you. So you have to choose what register you're starting, how many elements you will read, and all the stuff. Okay, but right now it's a library device, so it's preset for us. As you can see, I cannot change the name here of the variable, but I can change the name here. This is autogen name. Okay, so because this hardware name, it's always stored here for you to see which physical inputs it's your variable. So in case you rename it, you won't lose the connection with the physical input. Okay, so this is why it always is here, and you cannot rewrite the name, but you can change it by putting a new name here. Today I'm going to use a basic thermometer. It will be on my analog input 1, so I will just write temperature. Okay, this will be temperature. And when I go back to variable browser, I'll see that the MCO input, analog input 1 disappeared, and now MCIO2 temperature appeared here. Okay, so if I want to change the name of the variable, I can change it here. And if I want to change the name of the device itself, I can change it in its properties. So when I click it, so my focus is here, I can change it here. So I can just change it to IO. And you'll see that all the variables are renamed. Okay, and you can see here that there is IO temperature right now. Okay, just close this one and we can continue. I will create for you some very basic definition. It will be some kind of a regulation. Okay, it's not some very real one. It's just for our training purpose. So do not judge me by this regulation. Okay, and we will create regulation where we will compare two temperatures. One temperature will be measured, is the analog input 1, and the other one will be in a software. It will be just a software variable, and we will compare these two. One will be desired variable, and the other one will be measured variable. And we will compare our settings with reality, and in case the temperature which is measured will be higher than the set temperature, the system will have to cool, and in case the temperature will be lower than our set temperature and our set point, the system should heat. Okay, should heat. So we will use the two digital outputs to just present cooling and heating. Okay, so I'll just name the first one cooling, and this one will be heating. Okay, so it will be just very simple program. Okay, this will be all the physical outputs I would use and inputs. You can see it here in my list, in my variable browser. And this would be it. This would be it for a system part. Okay, so for a system configuration, I'm okay with this. I can go with a one Modbus channel with I/O, one I/O, and with one PLC Mark 420. Okay, so I'm good with this definition, with this system configuration. Okay, so right now I will continue with the programming. So in case of any questions for the system part, for a hardware definition configuration, you can ask me right now. And in a minute, I will continue with the programming here. Okay, so in case there are no questions, I will continue with the programming. To start the programming, you just can double click this main program. So this represents the program, okay? This file icon. It means this is a program, and you can deploy to your PLC. Okay, so when I double click, I see the main. This will be the first program that we will create today. When you open the programming tool, the program, you can see there is three parts. The one is this left side, okay, this table, and then there is a right side of the table. And in the middle, there is a working place. So the left part, we'll use the left part to create the inputs to our solution, to our program. It means that it will be the variables used for as inputs to our program, and these we will use as the outputs from our program. Okay, so I can add a new variable by right-clicking the table and by choosing the variables or global variables. The difference between global variables and variables is that the global variable, you can see the global variable through all the solution. I think the best example of it, it's the hardware variable. For example, the inputs we created before. So these ones are the global variables, and we can use them in multiple projects or function blocks. And then there is a local variable. The local variable you just use in this program, in the one, and it's not transfer to some other program. So it's only for your use in one program, okay? Okay, now we will create a global variable and we will insert the existing one, because right now we already created some of these hardware ones. So first of all, I will just click insert existing. And here I will filter our temperature, okay? So I'll just write temp and I will add the temperature here. Okay, you can see it here in our system. When I zoom it in, you can see there is a little dot, but when you see it from the zoomed, you see that it's actually a globe. It means this is a global variable. It has a globe icon. But normally you would see it only as a dot, okay, the strange dot. So if it has this dot, it means it's global. Okay, so IO temperature. Okay, I will maybe adjust it a little bit. You can adjust it, the program, as you wish. Okay, and there is some minimal size in this square. You can see this yellow square. Okay, I'll just adjust it to the, okay, to maybe better for you to see what I'm doing actually. Okay, so IO temperature, and I will add the outputs. So I'll just right click, global variables, insert existing one. And right now I will add a cooling. And I'll add also heating. Okay. So I have one input and two outputs right now. I'll continue with the creation of new ones because I need a set point. Okay, so I'll just right click, global variables, insert existing. Oh, sorry, create new. And I'll just write the definition here. Okay, so when I'm creating a software variable, I can name it any. I can name it as I want, but it's only I have to mention you cannot use some special symbols, and you can't use, for example, space. Okay, so if I write just set, okay, I cannot use a space here because in this name will be used in programming language in a structured text. So it has to be a variable name. So it has same rules for creating variable name, okay, in programming. So, and I cannot also use, for example, our check, these abbreviations here. You see, I cannot use these special symbols that are not used in normal, some general languages, okay. So I can just write a set point. In case I want to add some space, I can use the underline or dash or something else. Okay. Oh, I cannot use dash. You can see I cannot use only underline. So okay, underline. Maybe I can use also a dot, but I cannot use space or any special symbols here. Then there is very important thing, which is type. Okay, so the type of the variable. If you are familiar with programming, you may know that you have to choose the type in advance. There is some elementary types. In case you don't know it, then I will show it to you later in help. Okay, so right now we will add a real one because the real are a real is used for programming. Okay, it's used for analog variables. And okay, initial value. You always, it's very good to create an initial value here, because in case you are starting your project, it's good to have all the variables in some values that you are assume there will be these values during the run of the project. Okay, there could be a problem because when you don't fill anything in this space, there will be zero. So this is the potential problem. Okay, if you are, for example, cooling, or you want to run the heating and cooling in the room, the zero is not a very good value. So it's always good to write some value here. Okay, so I'll just write 24 degrees. This could be a good value for a set point, of temperature. So I just write 24. Okay. There is also this option flags. There is only one flag and it's called retain. This retain flag means that in case you check it here, then it will be saved in the memory of the PLC every time you change the value. Okay, so in case you are changing the value here, it will be saved in the memory of the PLC on every change. Okay, on every change. In case it's not here, if in case you uncheck this box, if you leave it blank, it doesn't mean it's not saved in the memory, but it will be saved in some general period. Okay, general PLC period of saving all the values. Right now, I will use the flag here because this is a set point, so I assume it can change very often, and it's good to have it in the memory. Maybe I will just explain it a little bit more. I mean, by memory, it's the flash memory of the values. Okay, so this is a values of all the variables I have in my project. Okay, in case I choose the retain, it means every time I change the value here, it's changed and it's saved in the memory. So in case I lose the source, I lose the power in the building, for example, all the values will be saved, which are retained. The other ones will be also saved, but only in some general saving period. I can see this period in the settings of the PLC, so when I click PLC, I can go here, okay? It's okay, it's where is it? Here, variable backup, okay? So this is a general period of saving all the values to the memory. You can enable it here, you can do it by some period, or you can do it by a trigger, by some trigger bool variable that can save you all the values in the memory. So in case you lose source, you lose power in your PLC, they will be saved in the memory, and after the start of the PLC, all the values will be on its the past values, okay, the last values. Or these which are not retained will be here in this period. Okay, reason why not all the variables are retained, because it will be very bad for the performance of the PLC. So there is a limitation for these retain variables. So I don't know exact number, it's some hundreds of the retain variables, but I only recommend you to use them on set points, on some variables that are not changed by, for example, measure. For example, the temperature, this is not important to have it in retain, because after the PLC start, it will read the value, read the fresh value. But here, on the set point, is just a software variable, so it can be problematic if there is some delay of your memory. Okay. Okay, so this is difference between these two, retain and not retain. Okay, right now I will create some basic solution here, and I will add some logic here. So if I want to add some logic, I'll have to change, okay, because here I have discard solution, and I'll have to change to function blocks. function blocks library. Okay, so there is some basic library here. And you can see that there are some options. You can browse through the library here. You have folders here. It's named by the purpose of the library. So you can see this analog boxes, some mathematical operations. There is also the digital boxes, some logical operations, very important ones, and or not negation, okay. Negation and counters, for example, the other ones, time dependent. Okay, it depends what you want to use. In case you know the name of the box of the library function block, you can write it here, okay? So right now I can write it here. I know I will just compare the values, okay? I'll just compare which one of these are greater than the other one. So I just write GT, which means greater than, and there will appear a block which is used for comparing two values, okay? Okay, so I'll just go with this block and I'll just connect it like this. So if you want to connect the variable, to write the variable to some input of the function block, you just click on this white dot, you hold the mouse and then attach it to the input, okay? So this is basically how you do the programming here. In case you want to see some properties of the function, you just click the properties here. Okay, you click the function on the function and you see all the properties here. As you can see, this is a very special function because you can add the dynamic inputs here, so it's not preset. You don't have to use two inputs, you can use multiple inputs here. Okay, so you can add multiple ones by clicking either here. Okay, this is one option. Or I will show it to you here also. This can be useful for you in case you are using, for example, AND function and you don't know how many variables you will compare. Then you can just click the dot, go on this yellow, okay, on this yellow plus, and you just go here with in, and it will automatically create the input in the function block. Okay. Right now you can see that it's in some period it's building on the back. Okay, it's building, and you can see right now it's built. It is blue here, this blue header. It means that everything is all right, that it has the right number of inputs, all the inputs are connected, and everything is right. When I mess something in my configuration, it will turn red to inform me that I'm not using, that it cannot be built, and I'm not using some proper programming, okay? Okay, you may ask why it's here dynamic when it's comparing functions, so how it works when there is more inputs. I can show it to you. You can see it in every function, on every function block. If you don't know how it works, you either can click it and then use function key 1, F1, or you can click the right and then help, okay? This section will show you the exact page with the definition of the function block, okay? And here you can see that the function compares two or more inputs. Output is true if every previous input is greater than every next input. Okay, example for 4 inputs. There is some example also. So in case you're programming, you don't know the exact use of the function or function block, you can see the help here. Okay, so it's very simple. You just click help or the function key 1. It will show you the page of the specific function. Okay, so right now I compare these two inputs and I'll just go with with cooling, I believe. Okay, where the temperature which I measure is higher than set point, I will cool. Okay, in the other, when it's opposite, I want to cool heat, so I will just find a negation. It's called not, logical negation, not. And I'll just connect it here, okay, to heating. Okay, so right now how it works, or when this function is true, when it's true, it's cooling. When it's not, then it's heating. When here is 1 and here is 0. Okay, so it's just the basic to show you how it works the programming here. And I will add some more blocks here also. Okay, so this is how you use the library functions and function blocks. Okay, the difference between function and function block. The function, it's, for example, these two are functions. You can tell it because it has a dashes here on the border, it has a dashes. And if I will add, for example, PID, okay, you can see that it's not dashed, it's the line. The border is line. It means this is function block and this is function. The difference between these two, the functions cannot save their state. Basically, it cannot save their state. And the function blocks, you can save the values here, the state of the function block, and you can also switch the whole function block to manual. You cannot switch the function to manual. If you want to adjust these outputs manually, you'll have to switch these inputs, okay? Because these are functions, you cannot switch them to manual. You just can control the inputs, okay? So this is a difference. The function blocks are more complicated ones. The functions are just the add, comparison, negation, and the simple ones, okay? Okay, so this is just for my words that I use. Why it's important to say function and function blocks, because it's all looks like a block, but some of these are just functions. They are not function blocks. Okay, I will add here. I will create our own function block. So in case you want to use something from a library, you go here, this page, and you choose it here. In case you want to create your own, you'll have to click here, okay, right click, add function block, okay. So I click function block, I just name it FB1. Okay, I just call it FB1, and then when I double click, it's open like this. It looks pretty much the same as the before. Okay, sorry. And right here, it looks kind of same, you see. So it's basically the same workspace, and we can work it is pretty similar. So when you right click, you can add the variable. But right now we will not use the global variables because we have to use the inputs here because we want to create a function block which will have some inputs and outputs. And we want to use these inputs and outputs here in our program. So basically, when you want to create a function block, it's when you have some part of your program which is repeatedly used and you want to save it so you can create a function block. For example, for one boiler, you will create a function block that controls the boiler. And if you have four of them, then you just add four blocks and just connect them to inputs and outputs, and it's working. You don't have to create a part of the program four times when it's repeatedly used. So you can create a function block for it and then use it in this project, or you can move it to other project and use it there. Okay, so in case there is some repeatedly used part of your program, it's very good to use the function block because then you don't have to create it again, and you can just add your function block and it will have all the features, all the functions that you pre-designed before, and you will just connect it to inputs and outputs and it's working for your project. Okay, so this is why it's good to create your function blocks for some repeatedly used part of your programs. Okay, now I go to the function block definition and I'll create an input here. So I don't go to global variables, I go to variables and I will click create input. That's the first option here. Okay, create an input. And we will use here function blocks. Okay, I'll first add here a function block that I'll use. I'll use a saw generator. This is a generator for a saw signal. So when I click it on help, I can see it here. Okay, so this goes on output, and I can control the maximum, the minimum, and the time that the block will hold the value. Okay, and also the time of the transition. So this is basically how it works. And I use this just to create some kind of the block. Okay, so I'll click here variables and create input. Now I'll call it like min, for example, for minimum. Okay, field type will be real, and the initial value could be nothing because there will be some variable connected. Okay, so there I don't have to write here anything, and it don't have to be retained also. Okay, I promised you to see the elementary data types, so I'll just click here, real. And in case you want to see the data types, I can write here elementary. Okay, not here, it's here. Elementary data types, okay. So these are the data types that are used in our Merbon IDE programming tool. Most of them are by the there are normal ones, which you can see in other programs. So basically bool, real, integer, time, for example, string, word, byte. Okay, but there is some others also. This is very useful for to see how many bits it takes to transfer the value, and also very useful is the range. Okay, because this can be problematic sometimes when the range is too low. For example, integer it only has to 30 to thousands. Okay, so when it's some higher value, it won't work. So there is some ranges. Okay, so you can see the ranges, the bits, and here you can see how you can use it, which type you should choose when you are programming. Okay. Okay, so we created an input. If I zoom it in, you can see there is a different icon than before. Before there was a globe, now there is a square with a arrow, and it means that it's input in our function block. Okay, so I'll just adjust it a little bit to be better. Okay, I'll go with this. Okay, I'll connect this one. I'll also create a variable for maximum value. I'll create one variable for enabled. Okay, I just call it n. Okay, it's not real. Sorry, it's not real. It will be bool. So in case I want to change the definition here, I have to cut it and create it again. Okay, so just cut it and create it again. Okay. In case I want to use more inputs, more visible ones, I'll just click the function block and I can allow to be visible here, okay, in this table. This is very important because in case you are using some kind of the function block or a function, all the inputs have to be connected to something, okay? All the visible ones. It doesn't mean all of them. There can be some hidden ones here, okay? But those visible ones have to be connected, okay? So in case that there is some blank one which is not connected, the block will turn red and you'll see that you have to change it, that you have to change the definition. You have to either hide it or connect some variable to it, okay? When it's not connected, it doesn't mean there is no value. Okay, there always have to be value when it's input variable. But in case it's not connected, the value is here in the table, okay? So these ones, these will be rewritten by the input, but these ones, these will be taken from the default values which are here, okay? So we can, for example, adjust it a little bit, okay? So I can write here 3 seconds. Okay, and I, for example, I can use this one also. So I'll just add invisible and show you the how to work with the local variable. Okay, what's the difference? You can move the variables by holding and moving it, and you can also by holding control or by choosing it like this, or by holding control you can choose multiple variables or function blocks and move it together. Okay, so I can do it like this. I'll just create a local variable. It will be, okay, what is it? It's, okay, it's time max, and it will be real also. As you can see here, there is a little lock. It means that this is a local variable. It will be only in this function block, nowhere else. Okay, and the difference between input and output, you can see it here. Okay, this here is this column, this gray column, is called overview. Okay, when you click it, you will see an overview of your function block. How the function block will appear when you add it to the solution. Okay, so this is how it would look like. I would have the min and max, and in enable these three will be for my for my controlling. I would be able to add variables here. This time max won't be visible. I won't be able to control it, okay, to control it from the external source. Okay, when I go back, okay, I can see there is some problem here. You see, there is this little window in the bottom, and it says that the expression type with real incompatible with input parameter time max. Okay, when I double click, it will navigate me to the space where when there is a problem. Okay, so in case I have some problem in my definition, in my solution, I can just double click the error and it will navigate me to the problem. And here I see, okay, this is red, there is a problem. And it's problem with the expression type. Okay, so I just write the wrong type, okay, because this is real. And when I click here, the time max should be time. Okay, so I have a wrong type of the variable. This is local variable, so I can change the definition. This is also a difference between local variables and global variables. In local variables, you can change the definition. So when I, okay, when I just, okay, I'll just have to, okay, no, not replace. Okay, I will maybe disconnect it and change it. Okay. I'm not sure why it's not here. Okay, maybe I'm doing something wrong because it's not working here. Okay, never mind. Never mind. We can delete it and create it again, but normally it should be we should be able to change the definition. I'm not sure why it's not here. I'll just check it one more time. Okay, here when I create some basic definition. Okay, I will try to add this one, but it will be the time value. Okay, so I'll just create it like this. I'll just try. Okay, I cannot see here. Well, maybe there is some slight mistake. So I'll just add this one and I will delete this one. Okay, it's not a problem for this time, but normally there should be a change of the definition for the local variables. Okay. Okay, I'll connect it. Now it's time. There is also time, so it should turn blue. In case I want to see it now, I can do the build. Okay, I can build it. Okay. So right now I will just create the output. It will be the output. So I click here, click variables, and create output. I can just call it out1. It will be bool, and I'll connect it here. You can also see the icon here. It's similar as an input. Okay, it's similar, but is the arrow from the square. Okay. Okay, you can also see some problem here. From real, okay, from real to bool. Okay, because it's a real. I misclicked it here also. So there is a problem with this variable also. I'll have to create it one more time. I'll just create an output and it will be real. Okay, I forget that this block, the output is real because it's showing us the analog input, okay? Okay. So here now I'm satisfied with my function block. You can see it here, okay? In the solution, you can see that there is function block 1. There is also a program here, okay? And I can see the overview. I will see that there is also out1 here, edit, okay? This is the overview how it will look in my definition. So right now I'm satisfied with it. I changed some values here. I use this variable to change a value here, okay? I can write, for example, 1 here also. So this variable will control this input. These variables will be controlled by external inputs, and the other ones will be taken from the default values here. Okay. So that's basically it. Right now, when I want to use the function block in my definition in the other program, this is the most crucial part. This is important because when I go here and I delete it, I don't see this block. Okay, it's not here. If I write FB1, it's not here. When I want to see it here, okay, I have to click the workspace, or to have a focus here in a solution in the tree, I'll just click it, and then here there's this checkbox, show in Explorer, okay? When I check it and I build the solution, so they'll be true, and I build the solution, now I should be able to see it here, okay? So when I go back to the library, I'll see here there is function block 1. Okay, it works. So here I'll just drag the block here, and I have it here in my program. I can hide this and output because I don't need it. I won't use it in my solution. I'll just use these ones, okay? And I'll add some global variables. Okay, not existing, sorry. I'll just use the new ones. Okay, enable, so be bool, initial value true, could be retain. Then I'll add some new one. It will be for minimum. Okay, not existing, sorry. It will be new. And yes, it's minimum. Be real. Okay, I should call it minimum because I used min before. I'll use 0. And I'll create one more. Be maximum real, and initial will be 10. I'll just connect it. And I'll see the block turns blue. Okay, it's called it's not connected. When I click it or I build it, it should turn blue. Okay, as you can see, the outputs don't have to be connected to anything. because the block only needs the inputs to work. The outputs are only optional. Okay. Okay, and we will do some uh, simple comparison function here also. And we will compare the output from this saw generator with, for example, sinus generator. So add this one. Okay, it's just this function. And I'll just connect it. I use these variables to connect the inputs also to make it easier. Okay. So I'll just compare these two outputs and I'll use this part of my program. Okay, so I'll just adjust it a little bit. I'll put it here and I'll copy it. So I can click copy or I can hold Control and plus C. Works the same. When I paste, I have this part of program. Okay, and I can use it here also. Okay, to control some actual hardware points, I'll just add some random ones. So I'll just go to global, insert existing, and I will use some digital outputs. So I'll just use digital output 3. I'll control digital output 3 and I'll control digital output 4. Okay. So here we will see one comparison, temperature and a set point, and here we just to see some run of the program. Okay, we'll compare the output of this function, saw generator, and the output of the sinus generator. Okay, we'll compare together, and we will see some process here. Okay. Okay, when you are satisfied with your project, you can build it. We did it before. When I click build, you can see that I can choose what I want to build. In case I would use multiple PLCs, there will be multiple PLCs, and I can choose only these ones I want to build. And I can also choose what I want to build. If I want to only build program, I want to build LCD or VAP in the memory of PLC, okay? Okay, so now I just click OK. I build it all. Okay, the solution succeeded. You can see the operations and actions or the results. You can see it here in this blue line, okay? In the left corner, left bottom corner of the screen. Okay, so in case you are doing some operation, some which takes some time, you can see if there is some process or if it's stuck. Okay, so you can see it here. Okay, right now it's okay. And if I just focus this build, you can see that there is save and build the entire solution. This is very important. So if you are doing a build, it will also be saved. If you are deploying, it will be save, build, and deploy. Okay, so it will do these three operations. So in case you are deploying, you don't have to build in advance. You just can deploy and it will save everything. Okay. You can also save it by clicking here. I just only have to inform you that there is no autosave. So make sure you are saving when you know periodically when you are doing some big project. In case some of your troubles with your computer with some unexpected error, you don't lose your job. Okay, so it's better to save it during the programming. Okay. Okay, so right now we have our program. our basic solution configuration. We created some logic here and we want to try it. But in this case, in this scenario, we don't have the physical PLC on our desk. So we have to use the virtual one. We will use the runtime, okay? So when I go here, I'll just go to the desktop and I'll run the Merbon RT. Okay, I'll run it. It looks like this. And I can just minimize it on my desktop, okay? Right now, because I connected the PLC manually, there is no physical way to contact the runtime now. So I just have to right click, attach, and I'll use the UDP broadcast here, okay? It should find me the runtime, which is running right now on my local host. Okay. I can see it here that there is some unknown PLC, okay? This is a physical one that I have on my desk actually, but we will not use it now. And there is some PLC from Wi-Fi, okay, which is in our office. And this is my runtime. I can see it by the IP address because this is the localhost IP address. Okay, so I'll just and I can download the configuration now because I'm using a real runtime. So I download the configuration. And you can see that there is a slight change here. Okay, now there is a 1 and 0.10 IP address. And the server is this. Okay. This is very important. These two IP addresses. The first one, this one, it's only stored in the project. This is used when you want to deploy a solution. You ask this address, okay? When you want to debug, that's this icon. When you want to connect to your PLC to see the actual recent values, this IP address is used also, okay? This address is hardware address, okay? So in case you are connected directly to the PLC, the IP address here and here should be the same. In case you are using some external PLC from public IP address, there should be change. There should be the public IP address and there should be the hardware address of the PLC. This works also for changing the IP address. In case you want to change the IP address, you do the change here, and then you upload the definition, upload the configuration, but you will leave this address because this means it will deploy the configuration to this address. Okay, so you don't, if you change this address, it will end in error because there won't be any PLC on this address. So this is used for connection of the program, and this is the hardware address of the PLC. Okay, so right now I'm using Windows Runtime. I can see it here in the type, assigned device type, Windows Runtime, okay? And now I can start debugging because my project is done. And yeah, okay, first I have to deploy it, sorry. So I'll just deploy it. I choose everything and click OK. You can see the process here, uploading image. And now the very important table appears. The program asks me how I want to start my PLC. Because when I deploy it, the PLC needs a restart. Okay, so I can restore it like warm restart or cold restart. The difference between these two are that the warm one, it means that all the values stays on its previous values. Okay, so if you make some changes, the values will hold the variables will hold their values from the previous start. When you click the cold restart, all the variables will go to its default state. So this is very important. So if you want to all your variables to go to the default values, you click cold restart. In case you want to let the variables to be on its previous values, you click warm restart. Basically, when you are doing your first preparation, you can use cold restart. When you are working on some place on project which is already running, you use warm restart. I think this is a very basic difference between these two. Then there is very important thing which is selected run mode. Okay, there is 4 options: full run, evaluation only, communication only, and commissioning mode. Normally, when you are working with a physical PLC on site, you normally start with commissioning mode. In commissioning mode, the PLC works as a converter, okay, for Modbus devices. Then you can proceed to the communication only. Communication only works only to control your values, to check if everything is all right, if it's communicating, if it's reading the right values. And there is evaluation only. Okay, there is no communication this evaluation mode, but it will run your program. Okay, and the full run, this is very simple. Full run, it's working as it should work. Okay, it communicating with inputs and outputs, and it's doing the program. Okay, program it's running. I will go back to this when we will use the physical PLC. Right now we will go with full run because there is nothing connected to our runtime and there is no problem with it. Okay, so I'll just go with full run and I go okay. I can see that the solution upload was successful. Okay, so I can start the debugging here. Right now it's online. You see that the values are read from the PLC. You can see that some of these are red. These two are red. This is because it's not communicating with I/O. I can check it also in variable browser. I can see that all the values from I/O are red. That's because my computer is not connected through Modbus to some, other device. So there is a communication error here. But the other values are working. Okay, so I can see this part of program is working. So okay, I can try to change some values. I'll write here, for example, 5 to see if it's working. It seems it's working good. And here, I want to check this part of program also, unless there is no communication here, okay? But I want to check it. In this case, I want to change the number here. If I write something here, it won't last here, okay? If I write 50, it will be rewritten by the 0 because it's the communicating input. Unless there is no PLC right now, I have to, if I want to do it to manual mode, if it's connected or not, it doesn't matter. I can do it, I can switch it in both situations. So I right click manual mode, and then check it here. Okay, now it's in manual mode, and I can rewrite the value to see how the program will react when there is, for example, 30 degrees. Okay, now I see there is true, there is false. It looks fine. When I put 20, it looks fine also. Okay, it's not very visible here because it's red, there is communication error, but when I do it, for example, in this case, you'll see that value will change to yellow to see that this is in manual mode. Why it's working like this by this checkbox? This is because you can choose multiple function blocks or values, and you can switch them all. Okay, so that's why it's working by this checkbox. Okay, so when I want multiple ones, I can do it like this. And I want to do the opposite, return everything to its state. I can do it like this. Okay. Okay. Something you may need for some further inspection of your program, you can use the charts. Okay, there is in the bottom of your page. I hope you can see it. Yes, I think it's okay. So the bottom of the screen, you can see that there is some options. Normally there is results to see the errors during building, but you can change it. You can change it to chart 1, 2, 3, 4. We have 4 charts, and you can add some variable. How to do it? Basically, you just right click the function block or the variable. Okay, so in case of the function block, I'll just click here and click add to chart. When I click it, there is a table of all the variables that are in the function block. I'll just use the out one, it's this one, and add it to the chart one. And I can see the variable value here. Then I go to the function block, I click add to chart and also choose the out, okay? And I can compare these two variables. I can do it either this way with two separate charts, or I can put them together to see the exact places when it's true and when it's false, okay? When the greater than function responds with false or true. Okay, so I can compare the functions here. If I don't want to update the visible content, I can turn this off by clicking here. Now it's stuck here, and I can just zoom it. Zoom to content. Okay, again, it's still recording the values. It's just not updating. Okay, so when I want to update it manually, I just click zoom. When I want to do it automatically, I just click update visible range. Okay, if I want to, for example, hide something or delete some data, I can just click here in the legend and click remove. I can also clear data by clicking this icon. So I'll just start from the scratch. I can use multiple graphs here. There is 4 of them. So if I want to add some variable, I can click here. Okay. To chart, can use some other one. And I can see the set point here. So when I change it, I'll see the changes here. So these charts could be useful when you are debugging to see exact values. Okay. Okay, this is for the charts, for the updating. I think uh, I think that for the programming part, this is everything basically. That's it, and I will show you the physical how to connect the physical in the next part. I will proceed to the physical PLC, how to work with the physical PLC, how to define the change the configuration of the Modbus devices using PLC, and how to do some other debugging with the physical PLC. Then, in the end, I will show you just some brief introduction to HMI, and that will be it for today. Okay, so right now I will leave you like a half a minute. If you have some questions, you can write it in chat, and then I will proceed to adding a physical PLC to the solution. Okay, in case there are no questions, I can continue. So I'll just stop debugging here. This is also important icon because right now you can see that I cannot close the window. Okay. When I try to close the window, I cannot do it. I have to stop the debugging first. Because right now it's communicating with the runtime. So I can close the runtime. And I will just plug in the PLC, okay, physical PLC to my computer. I'll just set the Modbus. Yeah, I'm sorry, I just forget to bring a cable, so I just need to prepare the one here. So just a second. I just connected my PLC to the I/O with the RS485. So I'll just fix it and plug it in the communication port 3, and then plug it to the bus on my I/O. Okay. Okay, right now it's connected. And I can attach the real PLC. So I'll just right click the PLC, click attach, and choose the first option UDP broadcast as before. But right now we will add the physical PLC. Okay, so here I choose this one, Mark 420, and click next. Okay, I'll just wait for this operation to end. We'll see if there is okay, incorrect IP settings. Yeah, this could be a problem because if you want to connect directly to the PLC, you have to set your internet connection to the same internal network as you have on your PLC. So right now, my PLC is in the network 1, as you can see in the address, and I have to have the same address in my computer. So I'll just change it. I'm sorry that this is not in English. So I just hope you will see it in your computer when you have the same problem. By the visuals and icons, so I just go with the Ethernet here and go to properties, and I choose the protocol IP version 4 properties. Okay, now I have a different address here, so I put 1 here, click OK. Okay, so when you have a different IP address on your computer, manual IP address, it doesn't mean you can't find the PLC. You can find it, but you cannot download the information and you cannot deploy the solution to the PLC. So right now I can do it, so I just click UDP broadcast and I'll do it one more time. Okay, download. Now it should work. Okay, succeeded. So this is basically it. When you have when you have this problem, this could be caused by your IP address settings. So in case of any trouble, go to network and internet, change the adapter, okay, properties, then Ethernet, properties, IP version 4, properties, and here there is a manual IP address of your adapter, okay? So when you are directly connected to the PLC, or when the PLC is on your internal network, you should change these options. Okay, I'm okay with this. Fine. Okay, now I can, because now I have here a Mark 420, and I have also a device identifier, which is a MAC address of the PLC. So this is also good because right now I can just deploy the solution because it has the identifier here, the type, and the correct connection parameters. So right now I will deploy the solution to the PLC. And I will start the PLC in the commissioning mode. It's very important, okay? So go to the commissioning mode first. When you are on site, you should always start with the commissioning mode because in the commissioning mode you can find the Modbus devices on the bus. You can change their addresses and you can make sure that it's communicating, that it's working. So in case you want to use Modbus devices, you don't need any converter to the computer. You can use our PLCs and Merbon IDE. In the commissioning mode, the PLC acts as a converter. Okay, so right now it's not computing any process, it's not computing any programming. It is just used as a converter, so we can change the Modbus devices addresses, adjust them in this mode. Okay. So first of all, we will change the definition of the measurement. So when I double click the I/O module and I go here, okay, so here I can see the definition. As I shown before, you can change the name for a software, okay, with this part. But there is also option to change the physical definition. You can choose between the current, voltage, and temperature resistance with 2 ranges. So this depends on the value that you are measuring. So in case you want to measure resistance, you just click here to resistance, okay? When you want to choose current or voltage, you choose these options, okay? Today I'm going to show you how to measure resistance and to convert it from resistance to temperature. So I'll choose this option, okay? and then I will continue with the configuration. But this option, it's very important because this is different option than the rest. This option have to be, this is a configuration, the physical configuration of the I/O, okay, on the module, on the device. If you change this definition, you'll have to upload the configuration to the device. So if you change it here, you have to upload it. You can do it by clicking this option, DOMAT configure module. If you click this option, it will automatically send you all the configuration changes by a Modbus actions to your devices. Okay, so we'll create the changes and it will write to your devices. But it's important, you have to do it. If you change the definition, you have to right click and click DOMAT configuration module. During this operation, you also have to be in the commissioning mode. So you can either switch the PLC to the commissioning mode, okay, clicking this, or deploying a solution and choosing a commissioning mode, or you can also, when you click this operation, it will check you the state. When it's not in commissioning mode, it will automatically change to the commissioning mode, and after the operation it will go back to its previous state. Okay, so but if you are changing anything here in the top of the properties, you always have to deploy the configuration by clicking this configure module. You can change the definition in multiple outputs or inputs. If you choose more of these, you can change it here. Okay, it's a group function to change it, but this says there is a multiple values chosen, so there is some change on the specific inputs. If I uncheck this one, you can see that now the error appears voltage because all of these inputs have this option chosen. Okay, if I add this one, this will change to multiple values. It means there is some definition change in the selected ones. It doesn't mean I cannot change it. It only informs me that there is some changes already. Okay, so I can do this manually like this, and then all the selected ones are changed. Okay, now I'll just deploy the configuration. I'll just need this, so I right click and do DOMAT configure module. Okay, there is timeout during communication because there is maybe change of the address. So I go here, I click DOMAT modules auto detect. Okay, I'll always have to be in commissioning mode during these operations, and I will check the addresses. I can change it here. Okay, if I need a more wide range. Okay, and I actually find one. I find this MCIO2 on the address 2. In my definition, there could be a problem because when I click the device, there is address 1. So that is why it's not working, why I cannot do the configuration. So I always have to check my address. If you are buying devices from our company, you can either have it in the factory defaults, then it's all the devices are on 1, or it can be pre-addressed for you. So there is two approaches. One is to see all the addresses, and the second one is to change them here. Okay, so you can either change them on the physical modules, so I can go here, detect the device, and change the address here. Okay, and also change the baud rate. I'll just go set, next. And when I do the hardware restart, this is important. When I change the address, I have to restart the module, okay, the device. So I just plug it out the source, and I'm just plugging it in. I just plug it from the power source, and I plug the power source in again to restart it, okay? And when I auto detect it now, sorry, okay, so the auto detect is on the channel, configuration is on the specific device. Just try to find it. Yeah, now it's on an address one. So this is one approach, and the second approach is to find the modules, its addresses, and then just go back to the project and change it here in the project. But it must be the same. So this address must be the same as the physical address of the specific device. Okay, right now I can configure the modules. So when I click configure, okay, you can see, and it's finished. Okay. So here, when I go back to the configuration, I can finish the configuration now. Right now, this configuration is inside my device. I will continue. This goes with the project. The other configuration stays with the project. So when I change it, I only need to deploy the solution, and it's there. Okay, right now I'll choose the function, transform function, and I will choose the resistance to temperature one. Yeah, the table changed, and I can choose the type. I'll use the thermometer PT1000. This is most used one, very commonly used. And now I have to change the definition here. These constants, are used in a formula, which is kx plus q. So when I add anything here, it means it will be multiplied. The value from the measurement, the resistance value, will be multiplied by this number, and this number will be added. So when I put 2 here, all the values will be multiplied by 2. And I can add, for example, 5 here. So it will add me 5 to the value, okay? Right now, I will just have to change it a little bit because I'm measuring on the range 16,000, and I'm just have 1,600 resistance. So I'll just go with 0.1. So the definition will be okay, because you can see that the structure type is integer, so it doesn't have the numerals here. It only have the integer ones, okay, the rounded numbers. So I have to multiply it by 0.1 to have also the numbers behind the dot. Okay, so these two constants are used for input, and these two are used for an output. So if I want to change the temperature, I would change these two. I can add something to the temperature. This could be very useful. In case you have a problem with your temperature, that your thermometer is not measuring correctly, you can change it here. If I add, for example, uh, okay, when I add minus 0.5, it will automatically subtract me the zero point 0.5 from the temperature. So I can adjust it to be correct when the thermometer is not working correctly. Okay. This is the basic definition. If you are interested in some more definition, you can go to help, find your specific device, not device but PLC, for example, and okay, you can see here some basic settings, how to adjust it. So in case you don't know what configuration you should use, you can always go here. Okay, you can always go here, find your hardware. Okay, so this, and to see what type of the configuration you should use. Okay. We'll use this configuration right now. Okay, we did the configuration, we changed the address, so we can move from the commissioning mode. So in commissioning mode, you changing the addresses of devices, you can auto-detect the Modbus devices, and you can you can push the configuration of the inputs or outputs to them. So right now I'll just deploy the solution. And I can move to communication only. Okay, solution was successful. I'll just move to my programming part and start debugging. And I can see that the definition seems correct. Because right now it's reading 24.3, which is kind of the real temperature that could be here, 24.3 degrees. In case you have some bad definition, there would be some nonsense number. You also see that the communication is working. Here in variable browser, the I/O is communicating. And in the communication only mode, you see that the program is not working. So if I change the value, no change there. Right now, what I can do here is to check if all the IOs, inputs, outputs are working. So I can check the inputs if they are reading the correct values. You can see the other ones are not connected, so they are reading something else. And I can also check the digital outputs. I can manually switch them now to true. Okay, so when I switch them, I see it on my I/O that the diodes on the lights on it are now switching, and it's also making a noise. I will try to move it slightly. Okay, just do the microphone so you can hear the change here. Okay, so I'll try. So if you will be quiet now, you could hear the noise. Not sure if you can hear this, but maybe you can. Okay, it's working. This communication mode it's good for you to control everything. You can change manually everything, every value. You can change it and see if it's working or not. Okay. When you are done, you can move to the next step. You can do it by deploying solution or you can switch the state here. In case you want to switch the state between these running modes, you always have to stop the PLC first. So I'll just stop it and proceed to the evaluation only mode. Now I'll start the debugging and I'll see that right now the program is running. But what it's not running, it's communication. You see that the value is not changing, it's stuck like this. And I can change it without switching to manual mode. I can switch it to anything I want. Okay. So I can switch all the values and try if my program is working correctly. Now see when I switch enable, this is in manual mode. Now it's working again. The difference between the evaluation mode and the full run is that nothing is going on the outputs. Okay, that's the main difference. So in this scenario, you don't have to be afraid of some changes to in your devices because nothing is going on the outputs. The outputs are dead now. You can only see how your program is running here. Okay. So you can also try the charts if you wish to. Basically, it's kind of the same as when you are running it on the runtime. But there is no communication here. You can change all the measured variables to your uh, points without switching it to manual mode. Okay, after I'm finished, I'll just stop debugging, stop the PLC and go to full run again. Okay, right now you may see you may hear the sound of my MCIO, which is switching now as the numbers are switching here. I can stop this by, okay, if I do here false, it stopped. And I can switch them manually here also if I switch it to some other. Okay, I'll try to do it as close as I'm possible. So I switch it here and you should hear the noise. Okay. Every time you are changing the value, you may see these two symbols, check uh, or X. These symbols, when they appear, you have to confirm the change. You have to click this check V or enter. Then it's saved. When I don't click this and I click somewhere else, it's not saved. So just make sure you are clicking this or you are clicking enter to save your changes. Then I can also try to raise the temperature. Okay, I'll try to raise it a little bit. Okay, the temperature is raised, and you can see that the program is working fine. Okay, this is for debugging. This is for run. And I will only show you some operations with PLC now. As I showed you before, very important thing is configuration. So all the configuration here, you can upload it or download it from the PLC. You can also reset to factory defaults here, or you can set up the time. You can change the time here. When I start debugging, one bookmark will appear here, one panel, which is called system status. And I see that, for example, now the time of the PLC is not the same as the time of my computer. So because the PLC was off for a long period of time, it changed a bit. You see, it changed a bit from the reality. So I can fix this by PLC operation, setup, time setup, computer time, and now the time is fixed. It was just few seconds, but it was different, so I just fixed it now. Okay. You can see here the communication, that the communication is running. In case you have some problem with your Modbus communication, you can see it here, some wrong packets, packet error ratio. If I, for example, pull out the Modbus communication cable, the serial bus, I pull it out, so there should be some wrong packets. And you can see that the number is increasing. When I plug it in again, the number should stop. Okay, it stopped now and it's working. So in case of any problems with your communication, you can see it here. Okay. You can see the function block here during the debugging. If I'll change it to true again, you can do it. You can change the values during the run of your project. You can either change values here, these changes are online, so you can change anything you want during the full run. Okay. So more to the PLC. One also very important thing when you have your PLC from our store, from our stock, you may need to upload runtime. In case you attach the PLC, and you will see some red triangle with a warning here in the runtime version, then it means you have an old runtime in your PLC and you have to upload the new one. And you can do it very simple by clicking upload runtime in PLC operation, upload RT here. Okay, I'll just stop the program now. And you can also switch between commissioning mode, full run and stop. And you can reboot PLC. This is a very useful feature because if you are not able to manually plug out and plug in the power source, you can reboot the PLC, you can restart it by clicking this option. So this could be useful for you also, because you can reboot it remotely. You can restart the PLC remotely and you don't have access to it. Okay, so these are okay. I think that's it for PLC programming. This is some basic information for you. I'll just check my papers if I told you everything. And after a short break for your questions, if you have any, I'll just show you a little bit about HMI programming. So to show you how to create a basic visualization, what kind of objects you can use, and how to run it in your PLC. Okay, so I'll just have a few minutes, like a minute break for your questions and to see if I told you everything, if I didn't forget any important, just to see my papers, and you can ask me anything now. Then I will continue with HMI. In case there are no questions, we can continue with HMI definition here. So till now I showed you the system and the executable projects part. Now I'll move to HMI projects. So I'll just right click the project here. It's pretty similar like in the previous case. I just right click and sorry, and click add new HMI template. I can call it like HMI or web. Okay. The graphic one template would be it could be a PLC, or I will show it to you on the terminal. Okay, so I'll just name it H2200. It's our touchable screen terminal. I can show it to you in help. Okay, so I'll just leave it like this. Yeah, and I have to create a terminal in my solution. So I'll just click here, system, right click at terminal, and it will be H2200. Okay, I'll just add that the PLC would be communicating with terminal is this PLC, because there can be multiple PLCs communicating with our terminal. And I will create a template. Okay, not existing, sorry, it's at new HMI project, sorry. Okay, here, template. Okay, I do it PLC. Sorry, I just have to delete it and create it for the terminal. And right now I can choose the specific terminal, it's this one. Click OK, and it's working now. If I double click the definition, there will be shown some basic blank space where I can put some objects. To add the objects, I have to change the card one more time. So we were in the solution part. We were here in the function block library. And there is another one which is called the HMI Gadget Explorer. This is a library for our HMI objects. They are either graphic gadgets or text gadgets. The text ones are used for LCD panels, and the graphic ones are used for graphics definition. So I'll just use these ones to show you some graphic definition. I think the basic types are the digital indicators and the analog indicators, now called value indicators, because they can indicate either real values or either string values. So it's called value indicators now because string is not an analog value, it's the string value. There is also some setters, these three. So this is for digital values. There can be either bool value or integer value. And there is analog setter, it's this object. Okay, so I can just basically show you how it looks like. Just very briefly. I will don't go to any further information. If you are interested in some more information about this, you can see our video of Merbon IDEA Advanced. There is more specific talk about this problematic. So you can see it here, and you can see all the objects and the definitions here. So I'll just add some analog value indicator. If you want to connect the variable, you just click here. You click on the object and then click here, and there you can choose the variable from your program. You can either choose some hardware variables, you can choose from program, or you can filter the variable. This is very useful. So I can choose the temperature here. Temperature, okay. Is there some problem here? Why it's not? Yes, it's IO, okay, IO. Temperature. Okay, I'll just choose it here. Now it's connected, so it will show me the input here. I can also do it as a setter. And I can see that here, okay, I can adjust it a little bit. There is some general options for visuals. You can adjust the color, the shape of your object. For example, the border can be transparent border, transparent background. Okay, foreground text. Okay, I can add unit here if I wanted to. Oh, that's basically it. I can adjust it as I wish. Bold. Okay. If you want to add a new page, you click this little plus here. So you can add multiple pages in your definition. Then the user will be able to switch between those pages in the menu. Or you can create a button that will be used as a shortcut to the other page. So if I choose the page ID here, this is now the shortcut to the page 2. I can do the same here to switch to page 3. I can write here 3, and here I can write just 2. this digital setter, it's used for setting the uh, digital values. I can do it to set, for example, some digital output. In case it's an integer and there is multiple values, you can add more values here, and you can define the text that should be shown when the value it's in the variable. So this is so I can write, for example, on off, or so power, it could be power on, power off. And this text will represent the value for the user. This is the value and this is the text that will be shown. I can also choose the image, and then the image will be shown instead of the text. In case I want to use some image, I first have to add it to my solution. So right now, if I add an image, I can only choose from these default images, okay, which are defaultly in my solution. In case I want to add some new ones, I have to add them to the solution first. So I right-click the resources, click Add, Image, and then I can choose, for example, from our graphics. You can download them for free. In case you don't have your own graphics, you can download our library with graphics here. Okay, it's either raster or vector. And you can add something here. Okay, for example, this, add this, and you can use your images also, in case you have your graphics, and add them to our solution. Okay, I'll just make it visible by putting this plain rectangle. This is just the normal rectangle, which is used just to some border or background. Okay, this is a Z index. That means should be what number is lower. It will be behind the other object. This is also very useful. And you want to put it here, you have to change it by this little options. So I will move it to increase. So now it will be shown here. Okay. As you can see, I have a grid on my screen. I can change the grid here, grid size, to some more useful for me. Then the images will attach to the grid. These other buttons are used to adjust the graphics. You know, there is some align here to right, make some width, decrease horizontal spacing. You can just adjust it a little bit if you want to, if you wish to use it kind of easily. Yeah. Okay, this is some plain text. This is just a plain text as a plain image. This is plain text. Just write whatever you want. Okay, and that's basically it. From the other, if you are interested in the others, you just can take a look at our other video, Merbon IDE Advanced. It's a record of our training. And here I will only show you how to, if this is okay for me, I just build it to make sure that all the objects are connected to some variables. It looks fine now. And I can see it here in the, okay, and I have to connect the variable now because I created the template, and I have to choose it here, that this variable will be used. This is important if you want to add the graphics. Here, if you will be doing a web, you will add this. Okay, it's here on the PLC. Right now it's here on the screen. So, okay, it's connected. And now I will be able to show you the preview of my graphics. So now the Merbon Visual application will start and I see it now. And I can control it also. You can see now it's not communicating because the PLC is stopped. So I'll just put it on. Now I'll go with full run. Okay, I'll just change it to full run. Okay, now it's running. And when I do show preview, it will be a live preview with my PLC, I believe. If I have a right definition. Okay, okay, now it's working, you see? So I can change the value here. I think this is a measure temperature, so it's overwritten every time I try to change it. So this is the not very good example of this, but okay, I can change it a bit. I'll just address this as an okay, this is only for measurement and this is for a setter, so I'll change this to set point. Global here, global variables, set point. I'll just build it like this. So even when you are not have a physical terminal, you can try to, if it's communicating, if your setting is all right, you can try to control it from here. Okay, so I'll just wait. Okay, now it's communicating and I can change the value here. And you can hear the noise when I change the value. This is also a control of one of the outputs. So you can hear the change here. Okay, and this is a shortcut to another page. Okay, fine. I think that's it for today. So in case you have any questions, you can ask me right now. Otherwise, thank you for your attention. I'm looking forward to see you on some other internet training, or I hope soon on some real training in person. So in case of any questions, just don't hesitate to write me now. In case you will find out soon in the future. I just remind you the context here. So technical support, this is our line. And this is our email. So don't hesitate to write us in case of any troubles with your programming. We can make an advice to you or write you some solution. In case of any further troubles, you can take a look in help. Try to find your problem here. This is very large description of all the possible troubles or functions. So take a look here. I recommend you to take a look here. There is very lot of the description of the operations. So in case of any troubles, take a look here. You can also visit our YouTube channel, which you are on right now. So in case you are interested in some other videos, other trainings, just take a look there. There is also a lot of them till now. There are some trainings and videos. You will see our previous definition. There is also in English language, so you can go to playlists and then see the English ones. There will be some new ones in a few weeks for the version 2.4. These ones are for the version 2.3. But in general, there is not some very big changes. It's the same, but there is some new features that we will make the tutorials for the new features in a few weeks. So in case there are no questions, thanks you again for your attention. I hope I will see you on my next training. I think in 1 month there will be training for SCADA Advanced. If you are interested in HMI SCADA, you can see our basics here. Advanced will be in 1 month, I believe. And as I said before, the Melbourne IDE Advanced is already recorded here, so you can take a look. You can proceed if you are familiar, if you are interested in something more about our programming tool. So now that's it for today. Thanks you again for your attention. Have a nice day. Take care and stay healthy, especially now. And I hope I will hear you or see you soon. Have a nice day and bye.